Hey, hello there. Let's talk about today's Leetcoding challenge question. Binary tree zigzag level order traversal. It's a slightly twist on top of the level order traversal. Given a binary tree, we want to return the zigzag level order traversal of the nodes values. So just ignore this zigzag for a brief moment and talk about level order traversal. Given this binary tree, if we apply binary tree level order traversal, depends on, we can easily do this with a queue, applying BFS with a queue. Depends on how the order we push the left and right children onto the queue. If we always push left before we push right, we're going to end up with the level order traversal like this. 3, that's the first level. 9 and 20, always left before right. And then 15, 7. So we do this level by level from left to right. That's the vanilla level order traversal using a queue when we push left before we push right. So this zigzag requirement is saying that it's not always left to right. We have to alternating in between the left to right, right to left, and then in the next level go back to left to the right. After that we go back to right to left. So it's alternating between those two orders. So instead of 3, 9, 20, 15, 7 in the second level here, it's actually 29. So it's in the other order. So a simple modification to the vanilla level order traversal to solve this is just apply it as usual. And after we get to the level order traversal, we look at the odd number of lists inside this list and just reverse those. It would be fine. But a better solution is basically when we're generating it, we keep track of whether we are at 0 or 1 or 2. Depends on that, we do this in different order. So that would be just a simple modification to the BFS queue level order traversal to this problem. We can also use a DFS to this as well. It's just that in DFS search, we no longer have this clear indication of which level the node is at. So we have to annotate the node with the level. So that's just making the problem slightly more complicated. In terms of time and space analysis, the time is always linear, no matter whether you do BFS or DFS, because we have to visit every node exactly once. In terms of space, if the tree is totally balanced, DFS will have a slightly advantage in terms of the space. It will be the height of the tree. So it will be much smaller than the last level of the tree, which is half of the size of the tree. The height is log 2 of the number of nodes in the tree, so it can potentially be smaller. Other than that, in the worst case, they are both linear when the tree is totally degraded. So with that time and space analysis and the slight distinction between DFS and BFS, I'm going to code up both so that you can have a comparison. First, we code up the BFS search solution, which is intuitively easier than DFS. So first thing first, handle edge case, garbage in, garbage out. Then we grab a queue. So initially we're starting with this first level with just the root node there, and we use a variable to indicate what level we are at. We start with 0, and we use a list to hold the level values. So we're gonna append a list of nodes values to this after we finish each level. So the looping condition is that whenever we still have work we do, we clear the full level in a loop. So because it's queue, we always pop from left. We use a list to hold the nodes values for this level. Depends on whether the level is even or odd. We either push on the right or push to the left. So So after we collected the nodes value, I will fill that out shortly. We will want to push the children onto the queue. So because we're pushing the left before we push the right, in the second level here, we're gonna pop 9 before we pop out 20. So when we collected the values, we want to append 20 before 9. So that's saying if the level is odd, we want to append those value to the left. Otherwise, we do the usual order, append to the right. After we finish this level, we increment this level. And also push this onto the result. Yeah, so that's the BFS solution using a queue to this problem. The only difference between this and the vanilla level order traversal using a queue is we note down the level, and then depends on even or odd level, we collect the nodes value in different orders. Yep. It looks okay. Yeah, so this is the BFS solution to this problem, iterative using a queue. Let's code the DFS. So the edge case handling is the same. Instead of using a queue, we are using a stack. So for stack, we can just simply using this, use a list. And we also gonna use this results to collect the level by level. So the DFS search for the stack, we gonna push two things onto the stack. It's gonna be a tuple of the node and also the level, because in DFS search we no longer can have a clear notion about which level we are at. There is no such a variable we can just look at and to determine which level we are at. So we have to annotate the node with its level. So, and also we are not able to append the level by level to this result. So anytime that we see a node of a higher level than we previously have seen, we have to add a new entry to this result. So this means that we are looking at a higher level than than what we already collected. We have to insert a new level into the result. Otherwise, it will be similar here. Just copy and paste that, and then this is also similar. So instead of just pushing a node onto the stack, we have to annotate the child node with the correct level, which is the parent node's level +1. So after that, oh sorry, this is different. Yeah. there's one tricky part here is that if we do DFS and we still push left before we push right, like a 3, 9, and 20, because we always pop from the right, we're gonna visit 20 before we visit 9. So we actually want to reverse this, so that we actually, in the DFS search, we visit 9 before 20. So if we do this, then the order that we collected the nodes value for that level can be the same as the prior. Otherwise, you will be problematic. So quickly check if I have problems. Edge case handling. Initial of the stack, it's the tuple of root node and the level annotation for that node. It's 0 in the beginning. The result is the empty in the beginning. In the first iteration, we're going to pop the root node out with the level 0, and we find that we should actually add a new entry to the result. So we push a DAG onto it. And then we look at the level. It's actually even, so we push the nodes value from left to right to this level, to the current level. It's 0. And then we look at the two children's right and left, and we push the children with the level +1 onto the stack. Because we push right before we push left, so it's 20 and 9. So in the DFS, we're gonna visit the left branch before we visit the right branch. So that's telling us the order we collect every level can be the same as the level order traversal. So append left and append depends on even and odd. If we do left and right, I guess we have to swap this left and append. So yeah, let's try to see if it works. It seems so. So it's accepted as well. The DFS is accepted as well. So it's a slightly more complicated in the DFS, but the BFS is pretty simple. It just to keep track of the current level you're looking at, and depends on that, you collected the nodes value in the alternative order. So that's that. So that's this question today.